Hi, I'm Karam and I'm going to be giving you a tutorial today on widgets and blueprint communications in Unreal Engine 5. Now, you may not be familiar with the term widget, but it's what Unreal calls on-screen motion graphics. You can have a heads-up display, you could have a menu, anything like that that comes up on screen and can be interactive is referred to as a widget. And these blueprints need to communicate with other parts of Unreal. So we are going to look at a few ways that communication can be done and get you on the road to understanding how to make a widget and how to communicate between the different parts. So you'll be able to create interactive in-game widgets in Unreal Engine 5 and choose between event dispatchers, interfaces, and casting as a means of communicating between the different blueprints you have in your project. I'm assuming you have a basic Unreal Engine 5 knowledge. You understand what the different parts are on the standard Windows setup, that you can create and edit a blueprint, that you get the simple blueprint logic, that there's variables, that there's events that can trigger things, that you have branches and you attach nodes, that sort of stuff, and that you have familiarity with actors, player controllers, and pawns. What I'm not assuming you know is anything about event dispatchers and the other forms of communication, blueprint interfaces, and widget architecture or UI best practices. We'll get into all this. We will start you on the road, but this will, not be the last stop on that journey. So if we look at what widgets are, these are on-screen motion graphic elements. It could be a HUD, like just a heads-up display, something that shows you a map of where you are and crosshairs. It could have your hit points on the side, how many coins you've collected, things like that. It could be a menu that you interact with, or it could be a pop-up that just comes on the screen for a short period or until you click that says you've collected 5 coins or something. So widgets are blueprints, but they are not actors because we don't put them in the outliner. They don't. It's not something you drag into a level. It is something that is created, shown, and destroyed by another blueprint. Their existence is temporary for the most part, and so they're only on the screen. They're not in the level per se. And so we've got a blueprint that triggers it. That brings it up on screen, and that's the one that should handle the overall logic on creating, displaying, and destroying. And any of that first step of communication should probably come back to that blueprint. So why don't we just jump right in and take a look at what we're going to be making ultimately. Okay, so to start, I've created a first-person template project, and I want to begin with creating a new folder to keep our files. So I'll call that tutorial files, and we'll start a new level, and it will be a basic level, and we will save it in our folder, level tutorial. Great. So with that saved, we're in good shape. So this is just a standard project you can run around using the WASD keys. And first up, we want to create a widget. So let's come here to User Interface Widget Blueprint, create a user widget. I'll call it WBP Menu, and let's open that up. So first thing we see here is the designer view. That's as opposed to the graph view, which we'll get into afterwards, but it's the familiar event graph you've seen in blueprinting. So here in the designer view, we've got the library and the palette at the top left, which are two views of the same things. And we're going to start off with what's called a canvas panel, which puts in our work area here, our design area, a frame, basically, that represents the computer screen, the viewport that the player is seeing the world through. And we can see that it has started to populate the hierarchy over here. So menu is the top level, because that's the name that I gave our widget blueprint. And then there's the canvas panel. And of course, like everything on Unreal, we've got a whole load of details here that let us control various aspects of it. I won't get into it because we don't plan to get into that level of complexity, but the documentation, as always, is fantastic. So first thing we want to do here is we just want to put a little bit of text that says this is a menu. So I will search in the palette for text. Here we go, text. I will drop it in. Now, for the placement, Unreal respects where I let go of the mouse, but it is anchored to this big star sun-shaped wheel. So that is the point that is the from which this element will be anchored on the screen. So if somebody's screen is smaller than the canvas panel dimensions, then the game is going to calculate this position from the top left, and if their screen is bigger, this will appear a bit closer to the top left, and if the screen is smaller than this, it'll appear a bit further out, and if you're doing a mobile game, it will probably be entirely cut off. So I want to set the anchor point because I want this to appear dead middle of the screen. So we come over to the details panel and I can choose the anchor point. I'm going to go with the center. Now Unreal is trying to maintain that position that I'd placed in the canvas panel, but relative to that anchor. It's just auto updated the position X and position Y of my element, of my text. So I want to make this 0 and 0. Now this has anchored the top left corner of it, which is still not what I want. I want it to be dead center. So we can go to the alignment, and if we go 0.5 in the horizontal and 0.5 in the vertical, it will align it completely to the middle of that anchor. I want to update the text block, so I come down to content. I'm going to say, this is a menu. And that has taken. But the justification of this element is still not center. So there's one more thing to do. You come down in the appearance details, and you can change the justification. So now it's actually center. I just think it's a little bit small. So I want to come up into the font settings here and change the size. Let's go with 40. That looks pretty good. So let's compile and save this and close, and we hit play and nothing happens. And that is because, as I mentioned before, there needs to be something in the world that is going to create the widget, bring it into existence in memory, put it up on the screen, and then ultimately get rid of it. So we need to create a blueprint to handle this. So I'm going to right click, blueprint class, create an actor, BP, let's call this box menu, because I'm going to make a little box to represent it so we know where it is in the world. I'll just save that. All right, let's open this up. In the components tab, I want to add a static mesh. There it is. And in the details, let's look for box. There we go, a good old box. 1 centimeter is too small, so let's make it 50 by 50 by 150, and compile and save. And let's just bring this out into the world and drop it down. Oh, of course, because I didn't change the contact point. So there we go. And if we play, our box is there. We can see it and run around it, and everything's happy. And now we can go into the event graph and we can bring it into bring the widget into existence. So the first thing we're going to do is create widget, and the class will be the one that we made, WBP menu. Perfect. The owning player is the player controller, so let's get our player controller and we'll plug that in there, and we'll make this show up on begin play. So let's compile and play, and nothing happens because we have created the widget in memory. We have not displayed it on the screen. So we want to add the widget. Oh, I can't pull off of there. Let me just do it this way. I want to add to viewport. I am blanking on that. Add to, there we go. So you do pull off the return value, add to viewport. I knew it was there, just took a moment to find it. Fine, so it is taking the return value of this widget that was created, and it's putting it into our viewport. So now if we compile and play, the menu is there. Now it's on the surface of the screen, right? It's not in the game world, so my player can't interact with it or touch it or do anything, but it is there. And what I want to do now is show you how we get rid of it. So first up, I'm going to just put a delay of 2 seconds so that we are able to see it for a moment. And then we want to take this widget and we're going to remove from parent. And I'll just tidy this up so that we can see what's happening here. So there's all of our code so far. All right, this is a menu, and it's gone. So that is probably the simplest version of a widget, but you know, you might want to put things that says game start, and that would be very effective, and that would be just fine. So I think let's just take a look at the notes here. So our order of use is to create the widget. Again, that's memory only. Want to add it to viewport. Now, player interacts and requests actions. That's what you're going to want to do if there's a button or something. And then we'll remove from the parent. So let's look at making the player able to interact with it. All right, here we are. So what you need to do is called set input mode. So there are 3 input mode choices here. There's set input mode game only, which is the default. That's what the game is like when you're able to move your character around. UI only disables the player controls and makes you able to interact with the UI. And then there's set input mode game and UI, which lets you do both at the same time, which would be helpful for a different sort of game, I imagine, like a point-and-click game. So here we have set input mode UI only. So this will disable the input of a game controller or the WASD keys. So the player controller is the same player controller, and we need to input this. And the rest can hold on. So I'm going to move this stuff down the line. Now our return value of the menu widget is getting a little bit far from the remove from parent. Didn't mean to do that. So let's store this in a variable, which will be very handy so that we can find it later. I'll just put WBP menu. So we have a reference to it now. So where has this variable gone? Oh, it's hidden behind, of course. So we go into here. I'll remove this connection. So that is what gets added to the viewport. We no longer need this, but we will need a reference to our menu, to our widget, to be able to remove it. Great. So I'll just move this further down. So we want to set the input mode to UI only, and then we're going to need to put it back. Set input mode game only. Otherwise, the menu will go away, and the player will not be able to resume playing the game because they'll be stuck with controllers that don't work. All right, so we've put player controller into set input mode game only, and here we've got get player controller into set input mode UI only. So let's try this now. So I've clicked into the window, and the controls weren't working for a moment, and now it's gone away, and it is. So at first look, this all works great, but what if I don't want it to just kick off at the beginning of the game? What if I want it to occur when we approach this box close enough, which is a bit more in the spirit of interactivity and gameplay? So I'm going to take a look at the viewport of our BP box menu, and I want to add a box collision. Great. So let's make it a bit bigger. Great. So now we can see that the box collision exists on all sides of our object, and I'll compile that. And then in our event graph, I no longer want it to be on begin play. I want it to be on component begin overlap. Great. So when the player overlaps the box, we will create the menu widget. We'll set the variable. We'll add this to the viewport so now we can see it. And at the same time, we will input mode UI only, so we can't use the mouse anymore, so we can't walk around anymore. We'll wait 2 seconds, we'll take it away from the parent, so take it off the screen and destroy it, and we will put the input mode back to game. So let's compile and check that this is working. So here I have free reign to move around as I want, and I approach. I can't move anything, and I can now. So that is working perfectly. So one thing to note is look what I've done there. As I approach, I'm holding the walk forward key, and then I lost control because it went to input mode UI only. So that is like the forward button, the input stayed resident in the memory and it froze that input while we went to UI only. So there's this helpful thing here on the set input mode UI only called flush input, which will tell the system when it goes into input mode UI only to pause or to zero out all of the player control inputs so we don't have the situation of the player continuing to run right past. There, it stopped me. So there we've created a simple widget that is activated by a box collision and removes itself. So that is really the basics of creating a widget. And of course, we haven't gotten into any communications yet because there's no interactivity in our widget, and that's what we'll look at in a moment. So here we are, our player interaction. We've discussed this, setting the input modes, and this is an important note here just for keeping things tidy. The blueprint that opens the menu should also be the one that closes it. I should say that opens the widget, because we don't want to have partial instructions spread out in unpredictable places. So the etiquette is, the best practice is to keep it all in the owning blueprint. So to recap, our widget is an on-screen blueprint that shows data and gives a point of interaction. It can give you information about the game. It can read variables on the player, like how many coins they've got or what the hit points are. It can display that. There's all kinds of great features that are built into the game already. You can find them in the palette that we looked at. And we don't want to keep data and information in the widget because, as you saw, it didn't live very long. So obviously your use case will have a different lifespan, but once you've removed that widget, you can't get information that was stored in it. So it's really not a place we want to keep in the information. So we want to keep that elsewhere in the appropriate place in the game, maybe in your player controller, maybe on your pawn. It depends what you're doing, really. And we can see that our player input can be controlled while displaying the widget. So we can limit it to only being able to use the mouse or something. Obviously not what you want to do for a heads-up display. You still want to be able to have the player move around, but it is an important part of using a widget. So let's look at what we want to do now. We've got a game event or an interaction like the player encountering the box collision, which triggers an event, which is the widget opening and the input changes. Then we'll have some buttons where the player can select an option. The widget will request an action. This is where we're getting into our blueprint communications. And then something in the world will change, and then we'll close the widget and the input will be restored. So we'll look at the first. So the first thing we'll do is look at creating a close button for the menu. Okay, back in our game here. Let's open up our widget. So this is a menu. Yes, it is. Now let's look for a button. Excellent. Let's add the button here. And of course, it's anchored it to the top left. I want it anchored to the middle. I'll set my alignments to 0.5 and 0.5. and I'm going to move it down. So I think that's in the positive direction. Yeah. The size is a bit small, so I'm going to make it 250 by 60, and that's all we want to do right now. I want to add some text. So let's bring some text into there, and I'll say close menu. I'll make it a bit bigger because I think that might be a bit tiny. Looks promising. So before we go into our graph view, I want to make sure that the button name makes sense. This is the name of our button, and I'm going to call it button 0, 0. And then in our graph view is where we're able to put in some blueprinting. So the first thing I want to do with button 0, 0 is, just with it selected here, we can see in our details, we've got some states on clicked, on pressed, on released, on hovered, on unhovered. So I want to first do on hovered, and let's get the button, because I want to know that the mouse is over it, and we're going to set the background color. Black is not what I want. I'll go with a nice green. Great. And then when it's unhovered, I want it to go back to something else, because having it stay on that same color will be confusing. I just want to check what the color is that we've got here in the designer currently. Got the button selected, background color. I'm just going to copy the hex, go back to our graph. Right, and the hex. Okay, let's compile and let's play. Let's come in here. So I couldn't see my mouse cursor. So that is because you actually have to indicate that it is shown. Set show mouse cursor. Not sure why it's not showing up. Let's turn off the the context sensitivity. Set show mouse cursor. Okay, so we will need to turn it off when we're done, and we're going to want to turn it on when the menu starts. So let's move all this to the side. And I'm actually going to turn off this part of the code so that the widget stays on screen so we can see what we're doing. Oh yeah, and the target needs to be the player controller, because it's this player controller that gets to see the mouse cursor. And we hit play, and we come in. All right, I've got the mouse, I can see it now. And closing menu, on hovered turns it green. When I unhover, it goes back to the color I had before. Clicking doesn't do anything yet, but that's perfectly fine, because that is what we have programmed it to do. So back in our graph menu, I want to now choose our button, and we're going to tell it what happens on clicked. So you could close the menu here. I could come out like this and say remove from parent, and I could set input mode to game only, get the player controller, and then we could show mouse. Not sure why this doesn't show up here. Okay, and then we could set show mouse cursor off. This will work perfectly well, but it is not best practice. So I'm going to click on close menu, and it works. So this isn't great, because best practice is that it should live here in the BP box menu, because this is the menu, this is the blueprint that created it. So let's grab all this code that we've got. I'm going to bring it down here. I'll get rid of the delay. And let's look at our BP menu, or widget menu. So we don't want all this to happen here. What we're going to want to do is create an event dispatcher, because this will notify anyone that's listening that the menu has sent a close request, that it wants an action to take place. So I'm going to hit plus here, and we'll call it close request. and I have to compile it. And then I'm going to right click, and no, I'm going to drag it out. There we are. And I'm going to call it. So we are calling the close request. The system is saying, I want to close, please. So in the BP box menu, we need to now tell this system to listen for the dispatches from the widget. So here we're going to take our widget menu reference, which is this that we've created there, just keeping this tidy as its own separate icon. And I'm going to pull off here and say close request. Bind event to close request. Okay, so we are telling the system now that when the close request is called, I want you to trigger this event. So let's create a custom event called close widget. We're going to connect these two items and now drag all this up. So this is the event called close widget. Remove from parent, set the input mode to game only, and get rid of that mouse cursor. So we need to know when this bind event to close request should happen. At what point in the game should the system associate the close widget event to the event dispatcher called close request? And that needs to happen after the menu has been created. If we do it before the menu has been created, then it's not associated to anything because the menu doesn't exist in memory yet. So we want to have this happen after the create menu widget. So let's do a sequence here so that it's tidy. And we can introduce this, let's say, after add to viewport. That's safe. All right, so when we add to viewport, it will set the input mode to UI only and all that. And then it's going to bind the event to the close request. So during the lifespan of this widget, there will be this association for the dispatch. And compile, and there's an error because, again, I didn't plug in the get player controller to the set show mouse cursor. Okay, so this is all good. And we will close these out and hit play and come forward. And if I hit close menu, the event dispatch was called. I think I did a clumsy click there the first time, close menu. Yep, it's all good. So that is working over and over and over again. Now, one thing I like to do, because I've found sometimes that depending on your gameplay, this box collision can get triggered a few times. I like to add a do once node. Okay, so it's going to do this once, but we need to reset the do once. It says here reset. So I'm going to get the end overlap. So when the overlap has ended, when the player moves out of the box collision area, it will reset the do once so that the menu can be called again. If I didn't do this, then it's only going to happen once in the lifetime of the game that it can create the menu widget. And we'll just confirm that this is working okay. You run up, close menu. Great. So we have a simple version of a menu working with a button, which is fantastic. Let's carry on with our notes. What we've done here is we've created a widget, which in the blueprint of the widget, you can control what you see and what can be interacted with. We made changes to the hover state, so it's a bit clearer for the user where the mouse is currently, which button you're over, and then we decided what happened on a click, and then we closed the widget. And we want to remember not to keep information, even though it can be tempting, even though the functionality is there for us in the widget. Unless you're doing something really quick and dirty and you're testing it, I highly recommend you do not keep data in your widget. It's just going to cause you problems. So I want to look at another form of communication here, and this is how we're going to look at making the player move. You can remember at the beginning we had two buttons. One made the sun move and one made the player move. And we want to use an interface to make the player move, because our box menu blueprint is going to request the player controller to perform an action. And we don't want to do it as an event dispatch, because then we've got an event dispatch in the widget is causing an event dispatch in the blueprint of the box menu, which it's starting to be multiple dispatches, and I've been advised it's just not best practice. So what we want to look at is an interface. So to compare the two, an event dispatch is something that you're broadcasting an event. So basically the system's saying the mouse button has been clicked. We don't know who's listening because it's in the blueprint of the listener that assigns that it's listening. So there could be multiple blueprints that get that message and respond. And the nice thing about this is the sender, the widget, didn't need to know who was listening, so it didn't need any references to them. And it's a short-lived disposable function, which basically says something happened, anyone who cares can react. Now, a blueprint interface is something that you call. You call the interface function. And there's a reference to the object, but it can be any class that has the interface implemented. We'll make that a bit clearer when we get into the blueprint of it. You have one target per call, so we're being more precise now than the event dispatch. But of course, you can just keep your nodes going and have a loop, or add other things that you're targeting. And this is really great for essential systems, like if you've got a save game infrastructure, you've got an inventory, like a fast travel or something that will need to respond to requests, but you don't want it listening the entire time because it's going to sit in memory. And so if we're using dispatchers for all these systems, you're going to have quite a lot of memory bloat, because the system is always like, I might be asked to save any time. The player might want to do some major changes to the inventory any time. It's got to be listening. So we don't want to do that. We want to invoke the interface, making the thing happen when we want it to happen. And a great thing about interfaces that we won't get into right now, but is there for further learning, is that you can pass information. So you can put a variable in there as you communicate to the next blueprint. You can pass other kinds of information. It can be very helpful and an uncluttered way of doing it. And what's so great is it's class agnostic and it's flexible. We don't know we don't know all that much about the other blueprint that's going to do something, which allows it to grow and change as your game goes on, and you won't have to come in and rewire it all up. And the kind of way of thinking about this is, I'm talking to you now, and I know you understand this request, as opposed to something happened, anyone who cares can react. So it's a more targeted action. Okay, so back in Unreal, setting up our interface is quite straightforward. We are going to search here for interface, and we're going to create a blueprint interface. So I'll call that BPI. I'll call that move player. And let's save that. And then we need to open this up, and all we're going to do is create the name of the new function. So I'll call it move player and compile it. And that's the extent of it. I would recommend you look further into it, because here you see the inputs and the outputs. This is where I said we could move information between blueprints, but we don't want it for this right now. Then in our player controller, which is where we're going to add the changes, we're going to need to add the interface. So if we come up here to our game mode, we want to use the first person game mode. Let's find our player controller. Now I'm going to make a copy of it over here in our tutorial files. Copy it. Here we are. BP toot first person. and I'll make sure this is our player controller class. Now let's open that up, and there's all that business that we don't have to get worried about. Let's go into the class settings, and we are going to add an interface, which we called BPI move player. Great. So we can see it's added itself here to the interfaces, and I want to implement the event. So now when this event is called, we can do the following code. So let's get our player pawn. Oh, don't drag off for that. Get player pawn. So what we want to do here is we're going to add player, we're going to add an offset, add actor world offset, and let's move the player. I just want to be sure something's happening here. 500, and we'll move up 100, so there's a little bit of a fall. And that is all we need to do here to set up our interface. It's really quite straightforward and simple. So let's go add our extra buttons into the widget. So here under button 0, we want to add button 1 and button 2. So I'll drag it in. What dimensions did I use? Was it 250 and 60? So we'll make it 250 and 60, and the alignment will be 0.5 and 0.5. I'll zero out the position, and oh, I didn't set the anchor to the middle. There we go. And now I got to zero it out again. And the position, I will move it down 200. Nice. Okay, so this needs a little bit of text, and we need to update the name so I don't get confused over which button I'm accessing in the graph. So let's add the text here. And I made the text larger, didn't I? It's 30. So I'll make that 30, and the text will say move player. Great. And we'll get the other buttons set up as we're here already. And anchor to the middle, position 0, and let's put 300 down. That'll be it. Size 250 by 60, alignment 0.5, 0.5, and that has lined up great. And the button name will be button 02. And now we want some text in here. So let's drag that text in, and we'll put the size at 30. And the name will be Move Sun. Great. So we've got our 3 buttons now. So going into the graph, we want to do all the same stuff here, the hovered, the unhovered, and the on-clicked. So I'll just do the hovered, unhovered states exactly the same. I'm going to copy the set backgrounds. I'm going to copy these 2 nodes, update the button to button 1 and button 2, and update the on hovered and on unhovered so that they all align. But we'll fast forward through it. Okay, we've got our hovered and unhovered states all lined up. Button 2, button 2, button 2, and button 1, button 1, button 1. Now we want to create an on-clicked functionality for button 1. On-clicked. So we're going to do another event dispatch, and we'll call this one move player request. And I'm just going to drag that in and call it. So call move player request. And why don't we set up the other one, even though we won't do the other end of the coding yet. So on button 2 clicked, we'll create move sun request. Let's call that. Okay, so this is all we're going to do in our widget. And if we hit play, we can see that it's been updated, and we've got our hovered states working. And when I click it, it's all working just fine. Actually, there is one thing I need left to do in the widget blueprint, and that is after I've made the request to move the player and to move the sun, I want the menu to close. So let's just check that this order is working here. Move player, yeah. Move sun, yeah. Close menu. Great. Okay, and back in our BP box menu, we're going to want to get a reference to our memory resident widget, and we'll want to bind an event to the move player request, and we're going to make that number 2 in the sequence so that it exists after the menu widget has been created. And we're going to create an event called add custom event, and we'll call this move player. And the way we're going to tell the player controller to do the event move player is by calling the interface. So we are going to move player. Here it is, class BPI move player message. And the target is our player controller, because that's where the function is. That's where the interface is sitting. So here, this offers us, as you said, a bit more flexibility than putting the code here, because we are letting the player controller, which governs the movement of our pawn, decide where exactly the player is moved. And let's see that this is working. Move player. Yeah, that's exactly what we've done. Great. So the last means of blueprint communication that I want to look at is a direct cast. So this is where we're going to tell a very, very specific element in a very specific actor in the game what we want it to do. So again, we're going to need to get the blueprint menu widget, and we're going to bind an event to the move sun request, and this will be the next element in our sequence. And we're going to create a custom event called move sun. Great. So now we want to get actor of class, and it is the sun is a light. It is a directional light. Great. And what we're going to do with it is we are going to do a flip-flop. So you click the button once and it'll move the sun to a new position, and then you click it again and it'll move it back. And so let's just look here at our directional light, our rotation. That's what we want. So I'm going to copy that rotation so we can restore it back to where it is. And putting it back will be the second part of the flip-flop. We're going to set actor rotation. I'm going to paste in. The paste doesn't work from here. So we'll do it one at a time. All right. Maybe the degree. So it's the degree symbol is causing a problem. Fine. And in here. Okay, so on the second part of the flip-flop, we're going to set the actor that is of class directional light to that rotation. I'm going to duplicate it now, and we're going to change the Y to -2 degrees. And so this is going to move the sun on the flip, and then on the flop, it's going to move it back. So let's compile, save, and play. Now, move the sun. The reason is because I didn't set the target for this bit. So there we go. The target is the actor of class. Classic. And hilarious. All right, good. So we come in here, move the sun. There, the sun has been moved. And come back again, move sun, the sun moves up. So there we have it. We've built our blueprint, our widget, and used 3 different forms of communication. Let's just review now some things that we want to talk about. So the blueprint interface and the casting. Why would we do one and why would we do the other? So we've been over the highlights of the blueprint interface. Basically, it's great for giving an instruction to part of the system that we want to do a thing, but we're leaving the definition of what that thing is in the other blueprint, which is great for flexibility in wanting to change later on who is doing the function that you're trying to accomplish, or what are the details of it. Casting is highly specific. I had to choose the directional light right there in our box menu blueprint. And so that makes it harder to refactor. If down the line we want to have not a directional light but something else, I need to come back, find how to cast it, and put in the details. So that's great for like prototyping or quick and dirty work, or if you have a reason for very tight specific communication. With casting, that also lets us access some unique data about the actor that we have accessed, which you couldn't do with the interface, because the interface is a one-way communication. But with casting, we're actually finding that thing and allowing ourselves to give it instruction or get information about it. Also with casting, you're not expecting to do multiple implementations of this action. You're not going to want to do a whole bunch of casting. You're kind of looking for trouble, for things to break down. So interfaces are great for letting systems evolve without breaking your UI, and can be a little less frustrating than casting when you're needing to identify the owner and the type and all that. So to summarize our 3 different modes of blueprint communications, an event dispatcher is ideal when you want to announce that an event has happened and let the identification of who is listening to happen in specific blueprints. Interfaces are ideal when you have lots of objects that could implement the same behavior, but you want to call a specific object and let it decide how to respond. So for a classic example of interfaces is that you've got a use button for the player, and there's all kinds of things that can be used. There's a TV that can be used that turns it on and off. A light switch turns on and off. There's something that explodes. There's a door that can open. And so there you'd be building into your player the capacity to activate an interface, so it can see if there's something in front of it, and whatever it is the player's pointing at, that thing gets told activate. So you'd have a blueprint interface that is called activate, and then in the object you would define what activate means. And you definitely wouldn't want to be casting that way, because you would then have to have in your player controller every possible object. Cast when the player wants to activate something, you'd say, what is this thing I'm looking at? If it's a door, open. If it's a light, turn on. If it's a box, open. If it's, you could have this endless list, which now really starts bloating up your project, and is not a great way to build it. So each of these methods of communication has its appropriate place, either through convention or through forward thinking on your project. So I encourage you, please, to go look a bit further into these, and you can find out a bit more about the nuance. And just as an easy one-line way of thinking about it, if a widget is talking to the thing that created it, in which case our BP box menu is talking to the widget, or the widget's talking to the BP box menu, using a dispatcher is an appropriate thing to do there. From the owning blueprint, the BP box menu, use an interface to talk to game systems and keep flexibility. So here we told the player controller to move the player, but we didn't define how exactly that is done. It could have been to an absolute place in the world, like, when you've got a world map and you can fast travel. We just did an offset. But that definition of what the move was kept in the player controller. And then for quick prototypes, casting is fine, but keep it out of the widget, even though you could do it in the widget. Yeah, so casting isn't bad, it's just very specific. Interfaces are flexible but more abstract. Dispatchers announce events and the listeners decide what's going on. And so our good design is choosing intentionally which method we're going to use. So to look further into it, I highly recommend you research Blueprint communication, Blueprint interfacing. There's great stuff on the Unreal dev site. You could also, to extend this project, you could add a key function to activate the menu, maybe put a Boolean variable on the player controller whether or not they have the key. So you could create a key object that's in the world with a simple menu that comes up, lets the player take the key or leave it alone, and the box menu only operates if you have the key. So the widget could then say the person has picked up the key, so it tells the key to update the player controller so that they have the key, and then there's a check in the Blueprint box menu to check the player controller if they have the key. So that's something you could do. You could also use this as the beginning of an inventory system. And how would you do that? Would you want to create an array? Would there be some means of creating a data set? Could you use this to remove from your inventory or buy and sell items at a store? What other menu uses are there? There's also lots of heads-up displays to let the player constantly know where they are on a map, or how many hit points they have, how many coins they've got. You can toggle the HUD, with a tab key or something. So I recommend you do look at the UE development community. You search on YouTube. There's lots of great stuff out there. And hopefully this has been a helpful first step on your journey to understanding about widgets and Blueprint communications. I wish you all the luck. And please do leave me some comments if there's areas of improvement or confusion, so that I can do a more helpful one next time. Thank you so much.